Hello good people, I'm going to explore how we can deal with inversely proportional ratios. 5 people have unloaded perfectly legitimate goods from the back of a truck in 36 minutes. What are the goods, I hear you ask? Well, much like asking your parents about the night you were conceived, there are certain images that you do not need floating around your mind. The question here is, how long would the same operation take with only 3 people? As usual, I'm going to create a table of the variables involved. In this case, we have people and minutes. The question is asking us, if we had 3 people, how long would it take to complete the task? From these two ratios, I can see that the number of people has decreased. What will happen to the number of minutes? If I have fewer people trying to accomplish a task, chances are they will need more time. This means that the number of minutes will increase. So, as one variable is going down, the other one is going up. They are moving in opposite directions, and therefore this is an inversely proportional situation. Recall that for directly proportional situations, I wrote a little d, and now I'm writing a little I, standing for inversely proportional situations. When I was dealing with directly proportional situations, I was dividing the numbers of my ratios. Now I'm going to do the inverse of division, which is multiplication. I'm going to have 5 multiplied by 36, and that will equal 3 multiplied by x. 5 multiplied by 36 is 180, and over here on the right I will have 3x. I need to transpose the 3, which means I need to divide both sides by 3. 180 divided by 3 is 60, and therefore x equals 60. This means that I could say that 3 people would take 60 minutes to complete the same task. Although this is my favorite method to solve inversely proportional problems, it is not the only one. By what factor has the number of people decreased? In order to answer that, I need to take 5 and divide it by 3, and that will give me 1.66 recurring. And if I take that factor and multiply it by 36, I will end up with 60 minutes yet again. Let me solve one more problem. My friends are helping me dig a pit. It takes the 3 of us 8 hours to finish the job. How long would the task take if there were 5 of us? I like to start by creating a table that shows the variables involved. In this case, we have people and hours. And the question is, if we had 5 people, how long would it take? Comparing these two ratios, I can see that the number of people has increased, and I need to figure out what will happen to the number of hours. If I have more people doing the job, chances are that the job will take less time, and so the number of hours is going to decrease. The two variables are moving in the opposite direction. Therefore, this is an inversely proportional situation. For the directly proportional situations, I divide the numbers of the ratio. For the inversely proportional situations, I do the inverse, multiplication. And so I will have 3 multiplied by 8 equals 5 multiplied by x. And that will give me 24 equals 5x. I need to transpose the 5 by division, which means that I will end up with 4.8 equals x. This means that I can say that if there were 5 of us, we would finish after 4.8 hours. As before, we can solve this problem by looking at the factor that is involved in the change. To determine the factor, I'm going to take the 3 and divide it by 5. That will give me 0.6. Now I can take that value and multiply it by 8. 0.6 multiplied by 8 is 4.8. We get the same result. Which method you choose to use is up to you. But please keep in mind, when dealing with directly proportional situations, all of the variables are moving in the same direction. Either they're all increasing or they're all decreasing. When we are dealing with inversely proportional ratios, we expect the variables to move in opposite directions. As one increases, the other one decreases. That is all for now, and I will see you on the flip side.